Hi, my name is Leo Dreger. Welcome to Cybrary IT. We're going to talk about image file forensics. Fun subject, but it's all scoped to just images. It's pretty much everything that you wanted to know about images and more. So let's go ahead and take a closer look. Some of the basic technologies or terminologies on images is how do we actually create them? And some images behave differently. Some of them you can stretch and scale and they zoom in and zoom out quite nicely. Or some of them when you stretch and you scale them, they get real graining. So they just take the pixels and they make them bigger, but they have no way of really getting into that minute detail. So you have vector, you have raster, and you have megafile. Those are the three major categories. You can look these up. They're relatively easy to find out on them. This is only the intro, so we're going to take a more detailed look when we look at some of the labs, and we'll talk about it a little bit further in detail. But just knowing the background on these is something you should be familiar with in just about any forensics course. So know the vector, the raster, and the megafile. The common things that we're always analyzing in the picture world, well, one, they're all images, but there's many different types of images. Again, this is OSI layer 6. And this is how we present things to the application. So we can present it to an application as a GIF or a JPEG, a TIFF, a BMP, or a JP2, a PNG, even ZIPs I would put in there. Because they all basically work the same way. And if you look at this from a compression and decompression standpoint. When it comes to the tools, there's literally no shortage of tools. I mean, there's probably about 100 of them that I could rattle off the top of my head. If you got familiar with about 4 or 5 of them, you'd start getting the idea. But this is another one of those things where you could search Google and you could literally just come up with program after program after program after program of how to actually manipulate and look at images. Some of them in a proprietary format, some of them in a not so proprietary format. So let's talk a little bit about compression. The theory behind compression is you want to take something big and you want to make it smaller. Okay, so one way to do that is to take all of the repeating patterns or a repeating pattern that you find throughout an image, and then take out that pattern that repeats itself and just put a placeholder there, and ultimately you can shrink the file. Typically, compression algorithms and encryption algorithms don't really play well together historically because they're very similarly doing the same thing. While encryption, takes a placeholder out and replaces it with or substitutes it out, or scrambles it with some other text or data. Compression will do it with the purpose of shrinking it. Okay, so there's a couple different types of compression encoding algorithms that one in the study of forensics should relatively be familiar with. You have Huffman encoding, Lempel-Ziv encoding, Lossy encoding, and then vector quantization encoding. Okay. And these are basically how the images work and how they compress themselves, and why some images, will be, 2.5 megabytes, but then if you save it in another file type or format, you can get that down perhaps even to a couple K. It really just depends on the application. Do you need something with a high number of pixels that's going to be maybe 5 megs for a picture, or if it's for a web page, something like a PNG or a GIF, they run a lot smaller. You can get those down into the teens of K size. Okay. Other than that, we have recovery. Okay, and there's a couple of different ways to approach recovery here. One, you can look at this from the tools perspective and running the tools and editing with tool editors. One of my favorite tools is DriveSpy. It's a real easy tool to use. But ultimately, you're going to take a piece of data and you're going to have to analyze that data. Layer 6 of the OSI model suggests that we can just use our file extension for that. But if you wanted to defeat maybe a content filter or something like that, you would just rename a picture from .png to .txt. And from a signature analysis point of view, the the firewall or the gateway appliance that's inspecting that code, they just typically look at the extension rather as opposed to quantifying the actual data as the data. All right. So one way that we can kind of play the same game is we can look at file headers. All right. If you look at a file header, you will see, it's like a GIF encoding. And in some cases, even if you have a corrupt file, by replacing a known good in JPEG header with the bad file JPEG header, you could actually recover that photo. So it's what we would do in the world of recovery to attempt to recover some sort of corrupt image. Also, carving techniques. Remember, carving simply means, looking for hidden patterns or data or values that are hidden inside the media. And then another tool that is very popular in the world of forensics is hex workshops or hex tools. Because here you can get the hexadecimal representation of the image, and you can look for patterns, and you can see, if you look at it from a hex point of view and use some of the hex tools, you can see common patterns, and if there's a corrupt piece of it, you might be able to replace it with another corrupt piece, an example, the image header, and things like that. But ultimately, we're trying to, one, identify the image files, two, evaluate them, and that's where all of the types and the terminology and the compression algorithms come into play, and then ultimately recover them so that, if there is a malicious image or a steganographic file or something like that, we ultimately can recover it. But like I said, there's hundreds and hundreds and hundreds of tools here. So nothing is more valuable than hands-on demonstrations of this. So let's go ahead and take a closer look.